So here we are with factoring completely. This is chapter 2, part 4. We don't necessarily have notes for this one. It's just the assignment. I suppose you could consider this first part here notes, but the idea is that we are going to try all of the factoring methods. So factoring binomials, which would be 2 terms, factoring trinomials, and 4-term polynomials all at once, just to see if we can figure out how to work through this as a group. So we are going to take a look at the following process. So remember that the first thing that you always do when you see a polynomial is to find the GCF and then factor that out. In fact, number 2 says divide out the GCF. So always looking to see if there's anything alike in both terms, all 3 terms, all 4 terms, so that you can take that out first. Then, if you have a trinomial, then you're going to look for what multiplies to be the last coefficient and at the same time adds to be the middle coefficient. There it is. The other piece there is that if it's a 4-term polynomial, then we're going to factor by grouping, which we have 2 strategies for now. All right, so taking a look at our first example here, and I guess keeping those instructions, I'm looking for a GCF. So anytime that I see an odd and an even number, a lot of times it's more difficult to realize there is a GCF, but it turns out that 7 can be factored or taken out or divided out of each of these. So if I take a 7 out, then I'm left with the 7 and the 7 canceling, and so just an x squared. And then the 28 and the 7 will reduce to be a positive 4. And so again, that's our answer. It's not a trinomial or a 4-term polynomial anymore after that, so we're just going to be done. All right, the next piece that we can look at is number 2. So we're deciding if anything can divide into both of these. And once you go through some of the pieces, it turns out that you realize 6 can be divided. Again, what do I mean by going through all the pieces? You just see what are all the factors of 42, for instance, and then match them with the factors of 72, just picking by dividing by 1, 2, 3, going through that whole mess, and then you realize that the greatest or the largest number that can divide into both is 6. So once you divide everything by 6, 42 divided by 6 leaves you with a 7, and then of course the x is carried along. And then 72 divided by 6 is 12. All right, the next piece is, again, a binomial, and we're looking for a GCF. So the greatest common factor of 6 and 12 is definitely a 6 in both of them. And then the lowest exponent power is a 2. So if 6x squared is divided out front, then we're going to be left with just an x from this first, because 6 will cancel, and then cubed reduced by 2 is just 1x. And then the next piece is going to be subtracting 2, because negative 12 divided by positive 6 makes negative 2, and then the x squares will end up reducing to a 1, which we're not going to include. All right, moving on to your trinomials. Again, always trying to find a GCF, so we're going to go through making sure that each of these is reduced as much as possible. In this first one, again, there's at least a 4 that can go into all of them. And then since 56 doesn't have an x with it, that's the only common factor that is within them. Left over after you divide out a 4 becomes x squared, and then 5 x's, negative 5 x's. And then a subtraction of 14. 56 divided by 4 is 14. And then we actually need to go through what is going to multiply to be negative 14 and also add at the same time to be negative 5. So going back to that kind of x method, we've got 14 as our multiplier and negative 5 as our adder. And so we're just going to try to find the factors of negative 14. So for instance, negative 1 and 14, or positive 1 and 14, negative 2 and 7, and then 2 and negative 7. And then that's it, and we're just looking for the ones that make negative 5. So that's going to be a 2 and a negative 7. So officially, our answer is going to be the two factors of x plus 2 and x minus 7. So that is that trinomial factored out. All right, then looking at number 5, let's see, the piece that might come out of each of these, notice they all have an x, and so the lowest power that can come out of all of those is x squared. That leaves the reduction of x squared, and the numbers will all stay the same, so negative 12, but then it's an x, and then plus 27, which will have no x's next to it. And so now again we're trying to find what multiplies to be this last digit of 27, but then at the same time we'll add to be negative 12. So taking a look at our x, we put the 27 down here, the negative 12 up here, and we kind of go through our list of pieces. So let's see, multiplying to be 27, but then negative, I'm going to go through all the negative ones. So negative 1, negative 27, 2, no, let's see, 3. Negative 3 is going to go in there, negative, what is that, 21, so 7, 8, 9, oh yeah, negative 3, 8, negative 9, and it turns out I'm going to stop there anyway, because that is when we're going to add to be negative 12. So negative 3 and negative 9 are going to be our two pieces of the factor, which means that our answer is still an x squared, but within our factor pieces, we're going to have x minus 3 and x minus 9. All right, then we take a look at the last pieces, and hopefully you notice that they are a 4-term polynomial, so we'll probably end up doing grouping. However, before we get to that, I'm going to double check that there's something that can't divide into all of these pieces. And it turns out a 6 can divide into all of them. And so we'll have 6, but then left over of x cubed minus 2x squared plus 4x minus 8. Then we want to start factoring by grouping, so we'll go ahead and group each of these pieces and then find out their greatest common factor within here. So, turns out x squared is the largest thing that can come out of there, but every time we do this, remember that 6 is still way out front. Then we have an x squared and our leftovers of x minus 2. Let's see which color haven't I used enough. Then we have our next piece, which will take out a 4. And so we have plus 4, and then the leftovers of x minus 2, which of course matches. And so that means our ultimate answer is going to be 6, and then we have our x minus 2, and then we have our leftovers of x squared and a plus 4. And of course, if you went through and actually distributed the 6, did a box, and got it all nice and expanded, you would end up with this initial problem up here. All right, and then our last one, the first piece is to find a GCF. And in each of these, we can actually take out a 2, they're all even, and an x. So if we take out that 2x out front, we're going to be left with the 4-term polynomial of, oh, my pen went off, no more 2's, so x cubed minus 3x squared plus 4x is left over, and then minus 12. Then we go through and group the pieces, so these two and these two. And the GCF of this first piece is going to be an x squared. Remembering that 2x is still way out front. And so the x squared will divide out of that second piece, and we'll be left with an x minus 3. And then to that second grouping, we have a 4 that can come out. So plus 4 and our leftovers of x minus 3. So those two black binomials are the same, and so we're going to go ahead and put 2x out front with an x minus 3, and then the leftovers of x squared, and then the yellow plus 4. Alrighty, so those are the factoring all types. So we had some binomials up here that just had a GCF, then we had some trinomials that also had a greatest common factor, and then those 4-term polynomials, which were factoring by grouping, also had a GCF. So key idea in most of this is to make sure that you're always looking for that GCF, and then after that you can go through the process of what type of polynomial it is.